For centuries, scientists were convinced they'd found a secret code in the sun's behavior, a simple, predictable rhythm to its fiery temper. But what if that whole pattern was just a cosmic coincidence? Today, we're going to dive into the science that's debunking a rule about our star that people held onto for a really long time. So this is the big question, right? Does the sun actually follow a secret even-odd pattern? For decades, this idea fascinated solar physicists. It was this tantalizing possibility that there was a simple, alternating rhythm hidden inside all that beautiful chaos. And for a long time, it really seemed like the answer was yes. It all started with a pretty simple observation. Scientists looking at the sun's 11-year cycles of activity started noticing what looked like a really strange but predictable rhythm. It seemed too consistent to be an accident. And it even got a name, the Gnevyshev-Ohl rule, or the GO rule for short. The idea was beautifully simple. A weaker, even-numbered solar cycle would almost always be followed by a much more powerful, odd-numbered one. It was like the sun worked in pairs, A quiet cycle was just setting the stage for a really dramatic one. Okay, so this neat and tidy rules seemed perfect. For a while. But then, as our tools got better and we started gathering more and more data, this simple little pattern started to look, well, a lot less simple. In fact, it started to show some pretty serious cracks. And it wasn't just off by a little bit. The problems were huge. Sometimes an even cycle was followed by a weaker odd one, completely flipping the script. Scientists couldn't even agree on how to define the cycles to begin with. And when they looked back over centuries of data, the pattern just seemed to disappear. The cracks were getting pretty hard to ignore. And this is where some researchers started to say, wait a minute. This quote from 2015 really hits the nail on the head. They started to suspect that the entire idea, the premise of forcing the sun's cycles into this even-odd pairing, just had no basis in actual physics. Maybe it was the wrong way to look at it all along. So with all this doubt piling up, scientists basically decided to, throw out the old playbook and start fresh. Instead of looking for this simple pairing, they decided to build a model based on how the sun's magnetic engine, its dynamo, actually works. And this new model takes a totally different approach. You can forget about even versus odd. Instead, it suggests that the strength of one cycle, let's call it cycle n, directly influences the probable strength of the very next one, cycle n plus 1. It's a direct, one after the other relationship, not some alternating pattern. So here's what the model found. If you get a really weak solar cycle, not a lot of sunspots or solar flares, that actually sets up the conditions inside the sun that make it highly probable the next cycle is going to be a real powerhouse. And yep, you guessed it, the opposite is also true. If you have a really powerful, very active solar cycle, it sort of exhausts the system, and it tends to suppress the strength of the one that comes right after it. It's this natural, self-regulating feedback loop. But, and this is a huge but, this is the secret sauce, it's not a perfect, predictable machine. The sun's engine is turbulent, it's chaotic. So mixed into this beautiful feedback loop is a big old dose of natural, unpredictable randomness. Scientists have a fancy word for it, stochasticity. So once they had this new, much more realistic model, one that included this cause and effect relationship and that dose of randomness, they could finally go back and put that old even-odd rule to the ultimate test. And what they found, oh man, it was a total game changer. They ran their new model to simulate 1 million solar cycles to see how often the old GO rule actually held up. The result? An even cycle was stronger than the odd one that followed it only about 45.5% of the time. Think about that. That's worse than just flipping a coin. So what does that actually mean? Well, it means there's about a 55% chance that any cycle will be stronger than the one before it. It doesn't matter if it's cycle 2 followed by 3 or cycle 3 followed by 4. The even-odd numbering is completely, totally irrelevant. Which brings us right back to the central mystery here. After all that observation, all that debate, does the sun actually care if a cycle's number is even or odd? And the answer, according to this amazing new research, is a hard no. That even-odd pattern that scientists so carefully tracked for centuries was nothing more than a statistical fluke. It was a classic case of seeing a pattern where one doesn't exist, simply because, for a long time, the limited data we had just happened to fit the idea. It was a cosmic coincidence with no basis in the real physics of the sun.
Okay, so why should we care about busting an old science myth? Well, this is about way more than just being right. It's about fundamentally improving how we understand and even predict what our star is going to do next.
So here's the bottom line, that even odd rule, it's not a real thing. The real pattern is this much more interesting relationship. A weak cycle is likely followed by a strong one, and a strong one by a weak one, all mixed with a healthy dose of randomness. By letting go of that flawed rule and embracing this more complex reality, we can build much better, more accurate solar models. And that's super important for protecting our satellites and power grids here on Earth.
And this whole story just makes you wonder, doesn't it? How many other rules or patterns that we think we see in nature aren't strict laws at all, but are just the beautiful, accidental results of underlying chaos and randomness? Makes you think.